All right, so today we've got a special guest lecture. I'll be helping out, but we've got a guest from the Writing Center, the UNL Writing Center, which is just across the way in Burnett. Andrews Hall. Dr. Meredith, Steck, that's right. Dr. Meredith Steck is here today, and we're going to be talking about how the parallels between writing, in particular drafting, and how that hooks into writing code, because you always want to be revising your code, revising your drafts in writing. In code, you're always refactoring your code to get it to be better, to work out the bugs, to get it to be more maintainable, and just overall better code. So with that, I'll go ahead and turn it over, but I'll be jumping in throughout the day here.
Cool. That is bright. Okay. Hi, I'm Meredith. My doctorate, so I'm the associate director of the Writing Center here, but my doctorate is actually in ecology, evolution, and behavior. So for my PhD, I studied insect brains, which was pretty cool. But during my PhD, I got super into how much writing I had to do and how hard it was. And then I got interested in how all different disciplines, from art history to archaeology to computer science, all use writing, and how important writing is for students in college to learn, and how different it is actually in each department. So now I work at the Writing Center, and I think a lot about this. I visit a lot with different departments and think about how we can teach writing skills to the students kind of in every different discipline. One qualifier is that whenever the Writing Center presents in any class, everything is always super interactive. So you're going to be writing during this. I am going to ask you to talk. I'll hold out the microphone, and it is fun to kind of have a back and forth and get a lot of different people's voices. If you don't feel comfortable talking, that's okay. There's a couple options. You can either talk to me off mic and I'll kind of summarize what you've said for everybody, or you can write down on the piece of paper we're going to give out, you can write down your answer to some questions, and I'll collect kind of the nearest 5 people and look at all of them and read all of them to the class, so nobody will know exactly kind of whose paper is whose. So there are a bunch of different options. The one thing I will ask is, I want to make sure everyone is sitting by someone else that they can talk to. So if you are kind of alone in your row, just move closer to someone so you could, or your group, feel free, you could turn backwards and talk to the person behind you, anything like that. Just make sure you're sitting in a spot where you can talk to another person real quick. Cool. During this part, if you want to just make sure everyone's got a paper. We've got some paper going around in case you need it.
Paper.
But yeah, just take a second.
Anybody?
It's just I'm going to be asking some questions, and you can write down some answers, and it's just easier a little bit. Some people who don't like speaking out loud, which I get.
Yeah. All right. Go ahead.
This is scrap paper, so you don't need to read it. I did not check what was on the other side of it. Okay, so while y'all are getting paper, I just want to talk about a little of why it's important to think about writing in computer science and in any discipline. So what I'm going to show you is some data from the National Association of Colleges and Employers, and that's kind of like a nationwide association that collects data on different employers, from the American Red Cross to Apple to Deloitte. Basically any organization that's going to employ college students. And in 2018, they did a survey about kind of what competencies were considered essential to all of these employers. So when you go out to get a job and you're going to interview with someone, what are they thinking are the most important skills that you need? And so here was the list. And I'll just first highlight kind of the top 4. So 100% of all the people surveyed, which was only about 200 employers. They surveyed a greater amount, but there's only 20% response rate on the survey. But this is about N equals 200, I'd say, on this survey. But all of them said that professionalism, work ethic were important. But I just want to highlight that oral and written communication is 95% of employers said that was a really, really key thing. And that can mean talking about your code, explaining your code to other people, writing a design document so that someone else can understand your code, communicating with other computer scientists, like all of that stuff, I think this shows is really important in an employer's mind. Now, here's one other interesting thing. The other column says rated proficient. So when employers said, okay, how good are our candidates at doing these skills? What they found was that if you look at oral and written communication, only 41% of employers said, oh yeah, people are good enough at oral and written communication. So my point in showing this is just to say, if you can practice communicating and talking about your code and treating your code like writing, you will probably set yourself apart from other people applying to jobs. And I do think it will serve you in the long run, kind of no matter what career you choose.
I would add that that's not just true of these employers right here. Our industry advisory board always says this. Anytime we have people come in, anytime we have companies come in and hold an information session downstairs, or like you're going to do next week when you go to the job fair on the 12th, I believe it is. Next Wednesday, not this Wednesday, but the Wednesday after that. Talk to employers and ask them, what do I need to be successful in your company? I'm sure that each one of these things will come up constantly. Our industry advisory board always says this. Employers are always saying this. And learning to competently communicate, oral and written communication, that also works inside this class. Because if you have a bug and you come to us, we're going to use basically the Socratic method. We're going to ask you, all right, what have you tried so far? Describe the bug to me. There is no way that we can help you if the only communication you give us is it just doesn't work, right? That's not communication. You have to come up with, these are the things I've tried. These are the things I suspect is wrong with it, right? Thinking that out and communicating it. Because remember, that goes back to rubber duck debugging, right? If you're able to communicate something to somebody, or if you don't have anybody present, you can put a rubber duck above your computer and start talking to it and start walking through your bug that my program's not working, this, I've tried this, and this. You will eventually come up with your own solution, because it's that communication, that process of communication has forced you to think it through. Right?
Cool. So that's just kind of a setup to say, like, any practice you can get talking about your code or communicating, writing about your code is going to, I think, serve you really, really well. Okay, so today we're going to do 3 things. And the first they're all kind of writing skills that I think also apply to coding, and also I think will serve you in this class. So the first thing we're going to talk about are free writes, and kind of thinking about the parallels between the writing process and the process you use when you code. The second is reverse outlines, and I'll tell you what that is, a very useful technique in writing that I think you can also use for coding. And the third is we're going to look at, so you're going to be writing like a lot of new types of documents and new types of writing, I think, in college. And it's hard sometimes to know how to write something if you've never written it before. So maybe this will be your first design document. So we're going to talk about how to look at a sample that maybe your professor gives you and how to take that sample and kind of imitate it in a productive way. So that's kind of the plan of what we're going to do today. So let's start with free writing. So free writing, reverse outlining, and kind of how to analyze a document that you might get from a professor as an example. Okay, so free writing. Free writing is kind of, how many people have done it, first of all, ever? In any class, ever? Okay, like a handful, maybe like a quarter of you. It's basically just you write whatever is in your head right away, and you don't hold yourself back. And if you can't think of anything to write, you just write, I don't know what to write. But the goal is kind of just to get your ideas out there. So we're going to do this really quick. There were some articles on Canvas, and one of them writing good code is like writing a novel, kind of argues that the process of writing code is kind of like very similar to the writing process. And in one of those paragraphs, they focus on drafts. So I just want you all to reflect first on the steps that you take when you write something to get from that first idea to the final draft. Like, what actually do you do? And then I'm really actually interested in this one. How is that? So think about this for about 2 minutes. I'll give you 4 total. And then second, how are these steps similar to your coding process? And this is the one I'm going to go around and ask folks about. So if you're brave enough, I'd love for you to talk. There's no right or wrong answer. I'm really looking for actually a variety of answers because I think everyone's process is actually a little different. But if you don't feel comfortable talking, make sure you've got something written down and I can grab the paper from you and a couple folks around you. But I'm going to give you 2 minutes. I'll give you 4, and I'll tell you at the 2-minute mark so you can move on to kind of this question. So again, a free write is just writing whatever is in your head. It does not need to be good. It's just kind of a way to get your ideas kind of flowing. Okay, are you ready? I'm actually going to time it. So, yeah, this is about speed, not necessarily like polish at all. Okay, ready, set, go. Okay, if you haven't already, go ahead and switch over to that second question. How are these steps similar? The steps that you take in writing a paper, how are they kind of similar to how you might actually write code?
You'll both be there this afternoon. Okay.
Take about 30 more seconds. right. So again, couple options for sharing. Can I grab, anyone have some answers over here? I'll pass you the microphone, or you can, yeah? Okay, awesome. Thank you very much. So that second question, how, if they are similar, or maybe not, how does your writing process compare to your coding process?
I often try to write down a big picture and then break that down into smaller steps that I'll need to accomplish, or each step in the process needed for the final product.
Yeah, I totally do that with writing, and I think I do also do that when I code. For my PhD, I had to code in R a little bit, and I would definitely write out those big tasks, and if they were so big that one line of code's not going to get at it, right? You think okay, what are the sub things? So you kind of make an outline before you write. That's really helpful. Anybody else? Yeah.
I said, when you're writing, you translate the ideas that are in your head into language, but when you're coding, you also do the same thing, because you translate, the process that you do in your head into something a computer can understand. And it's at, different levels. When you write, you figure out what are the right words, and then what's the right sentences, and what are the right paragraphs. Mm-hmm. And when you're coding, it's what are the right blocks and lines of code and everything.
Actually, I have a genuine question. Is the audience for code, obviously the audience is the computer, right? Because the computer reads it and does the thing. But how much are other people an audience for code?
Does anybody want to offer an answer?
I'm genuinely curious, as someone who is not.
Yeah, go ahead. Just say it.
People are a pretty big part, especially when you work on big projects. That's why we have documentation, is so that people can go back and read what your code is doing, what it's trying to accomplish. And then, if there's any errors with it, they'll understand, okay, well, this block of code does this, so there must be an error here. Let's see how this works, and that's how we try new ideas. So it's a pretty big part of working with other people.
Exactly, and if you don't have the proper communication in your code, that is badly written or undocumented, then you're not communicating to the maintainer, and it becomes a completely unmaintainable code. So documentation is definitely the message to the other people that are reading your code, but then also making sure the code is self-documenting, in that it is self-evident to somebody who knows the language, what you're trying to do and what your intent with the code is.
So it says the computer reads it, other people read it, your future self, when you're error correcting, also might read it. And that to me sounds a whole lot like writing. In terms of any type of words that you would produce are designed to help other people kind of understand what you're doing. Anybody else? I'm curious, do any of you have other people read your code before you hand it in? No. I'm hearing y'all are laughing, which is pretty funny. Why the laughter? I'm just curious.
Plagiarism.
It's plagiarism.
It's plagiarism, so other people can't.
But last semester, all the hacks, right? Many people chose to work with other people, and you had multiple sets of eyes on a piece of code. You went back and forth and said, no, that doesn't look right, or no, that's a terrible variable name because I have no idea what you're trying to say there. This semester, now that we're into the project phase, you have the option of teaming up with another person, which goes back to what we were talking about before, that communication is absolutely essential, because if you choose, and I highly encourage that you do, choose to work with another person and pair up, then you're going to have to bounce ideas off of each other. You're going to have to clearly communicate with each other. If you write a piece of code and push it, hopefully you're using Git as well, and push it to a repository and your partner sees that, they have to understand, why did you write that piece of code? Right?
And lastly, so being that you can't share it with other people, how do you revise your code? So you've written the first thing. What is your, I'm curious about, does anyone have a kind of a methodology for that? For getting to the next, thank you.
Well, a lot of the time programmers will write the famous to-do statement, which is more procrastinate, I'll go do this later. But
so this is for yourself?
Yeah, you're
okay.
So here's this thing I need to do. It's going to be a little complicated, so I'll get back to it later.
Okay.
But when you do get back to it, usually your first thing is just what resources do I have available to me to accomplish this task.
Okay.
Other than that, if you have somehow already accomplished a task but it's ugly, then the next thing is to figure out a prettier way to write it, basically.
Okay. And to
What is that called again?
refactoring
Exactly.
your code. Okay.
You're not changing a fundamental functionality. You're changing it so that it is clearer, that it's more concise in some cases.
I totally, when I write, like if I'm writing a scientific paper, I definitely write the easy bits first. Like I'll write the methods because those are done, right? I did that. I know why I did them. But then, the intro and the discussion can be harder because that's more conceptual and creating an argument and all of that. So I think that definitely parallels writing. So I think free writing in and of itself, just kind of getting your ideas on a page really fast without holding yourself back, can be super useful for pre-coding, right? Before you even sit down to write, this person over here said, hey, I think about the big problem and then breaking it into sub-problems. You could do that in an outline. You might also just time yourself for 10 minutes and just go, okay, what are the problems? What's going to be a sticky part? What's not going to be a sticky part? I find if I go into it with kind of that overall view, both my code and my writing get a little better.
And that solves the I don't know where to start problem. That if you don't know where to start, you start outlining. Okay, well, I'm going to have to read from a file, so obviously I'm going to have to open a file, and read it line by line. You might not have the entire details there, but you can. That's your starting point. Just write something down. Not code, but a note to yourself, a to-do. I need to open up this file for processing. I need to do this. I need to do that. And then you come back in and start filling in those details.
Totally. And I don't think it even needs to be in order. The goal of free writing in general is to get you unstuck. So in writing, I do this when I'm like, I don't even know what to write right here. And I'm like, okay, 5 minutes. I'm going to dump everything I know about this topic on this page, regardless of whether it's useful or not. And usually just from that process, I'm like, okay, this theme came up. I know that's important. Maybe I'll just start there, because you have to start somewhere, right? So I think it sounds like for coding, that could really work as well. Awesome. Okay, let's move on to the next thing we're going to talk about, which is called a reverse outline. So we mentioned that you can outline before you write something or before you code, but you can also do it afterwards. And this, for me, this has become like the number one useful tool in grad school. Is reverse outlining. So you start with a complete first draft. So you write a draft of something. And then what you do is you take kind of each paragraph or each unit of subunits of your entire structure, in many cases paragraphs, and write the function in the margin. So you kind of come up with an outline. Like if you have 6 paragraphs, you'll have 6 statements about what is in each of those paragraphs. And then you just number your paragraphs. So I'll give you a quick example of what this could look like. Let's say we're reverse outlining. This is a job application. And you can see I have 2 paragraphs here. And if you were to define, just look at this first one. I am writing with great enthusiasm to apply for this position, and I am currently blah, blah, blah. If I were to give that paragraph a function, I might say something like, the function of it is to introduce myself to whoever my reader is and kind of state the purpose of this letter. So purpose and introducing myself. Then that second paragraph, I have this many experience doing this, and I'm currently in my current position. I'm responsible for this, this, and this. So that kind of function is going to be explaining to the reader why I'm qualified, right? If I'm going to summarize, so I'm summarizing the function of each of those paragraphs. And what that can really help you do is if I go through one of my drafts and I can't identify a function of it, what am I doing in this paragraph? There's usually a sign that that's a spot for revision. And it also helps you kind of see the flow of an essay in kind of an abbreviated way. But we're going to think about how this might actually be useful for code as well.
Before you go on, I'd also say that reverse outlining like this also exposes redundancies. So here there were only 2 paragraphs, but if there were 10 paragraphs and paragraph 2 had the exact same function as paragraph 8, then merge them, get rid of one, right? Choose the better one,
So
whatever.
the cool thing, like, if imagine this cover letter were like, 7 paragraphs, and I needed to get it to a page, and it was like a page and a half. And maybe like this paragraph was, explaining what I do at my current center, and then the second paragraph was like, oh, and in the last job I had, I did this, 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 and this. These 2 paragraphs explaining why I'm qualified might have been the same. And sometimes it's good to have 2 paragraphs about why you're qualified, but other times maybe just one will suffice. And you maybe think maybe I could combine those 2 experiences. So it just gives you an idea of what your letter or what your piece of writing is accomplishing, and how those parts fit together. But let's do an example with coding.
So this is an example that I've used before in other classes. It's used in biology sometimes for DNA. And what you're doing is you're generating a suffix array. So given a word or given a string in general, in this case we're given science, then we identify the suffixes of that. Now, by the suffixes, we just mean the ending part, the ending substring. So science itself is a substring because a substring is always a substring of itself. But then if you started at the second letter, then it's just science, however you pronounce that, ience, ens, the rest. And then you sort it in lexicographic order. And so given this input right here, science, this is the output that we want. Pretty straightforward, pretty simple to understand. So
what I'm going to show you on the next slide is, that's the task that the code has to accomplish. So I'm going to show you on the next slide is example code. And what I want you to do is kind of, just like I had on the previous slide with arrows for each of the paragraphs, I just want you to do that with the code. So break the code into units that you think are kind of meaningful chunks of code, and draw arrows. On your paper, draw some arrows to say what each of the functions of each of the sections are. So here's your code. So take a second and write down feel free to talk. Yeah, why don't this one we could do out loud. Maybe talk to the person next to you about what these yeah.
the input is in arg0.
I should remember to do some talking, not just writing. Okay. So,
Yeah, who wants to identify the first block in their reverse outline?
Creating all of the substrings and storing them.
So, the nice first block right here. Okay. By the way, stylistically, how did you know? How did you have a visual cue that was your first block? Indentation. Indentation.
Double space.
And spacing, right? So, good use of white space. Right? Not every line needs to be double spaced, but you chunk lines together. This all basically is the same thing, all part of the same function of it in your outline. How about the second one? Good. It's sorted. So where does that go to? What does that go to? Something else we've just mentioned. That code is self-documenting, right? You didn't roll your own sorting algorithm. It's collections.source. It's self-evident, right? And it's absolutely clear what the intent of that code is. How about the third?
You print out the list.
Okay, good. You print it out. Next.
Go ahead.
Okay.
So yeah, we came up with a kind of reverse outline.
And indentation, again, another point that comes up all the time. In an outline, you indent, and then you have subpoints, and those are all at the same indentation level, just like code. Subpoints of subpoints are all at the same indentation level. Now, just like an outline, right? You start running out of capital Roman numbers, then A, B, C, and then lowercase Roman numbers, and then then you start to run out of them, and you run out of them for good reason, because deeply nested stuff is confusing and unclear. Look for shallow nesting, right, in a lot of your code. Right?
Okay, so let's try one more example. So do the same thing. Just talk with the next person and maybe collectively come up with a reverse outline for this code.
It does the same thing.
Same task. Same task.
Anyway, make an array that exists. But you're splitting. Wait, no, you're splitting X. And you're putting it into the template. So what is X? Oh, yeah. And nothing. So, yeah. So you're splitting it between nothing and well, maybe you're just splitting it. Yeah, no, you're splitting it. So, yeah, you're making so character by character. Character by character. But yeah, you're putting character by character. You got us.
All right. Instead of having you share your outline, I'm just going to write this, right? Because it's kind of crazy. But what I am curious about is what is different about this code than the last one? What makes it difficult to reverse outline? I'm gonna go over here. Anybody over here want to tell? Yeah. Thanks.
It's really complicated, and it's kind of like reinventing the wheel in a less.
Can you say more about I don't know, what does reinventing the wheel mean?
It's just like
because I don't.
Recreating something that's already been created.
What does this do?
Can you tell me more concretely? Yeah.
So like for that, there's it's like comparing them and sorting them, and in the other code there was just simply one line that already did that.
Okay.
And
so
this
one did in 10 lines. So in terms of comparing the suffixes and sorting the suffixes, right?
Yeah.
So this one did in 10 lines what the other one did in like one line. Okay.
Yeah.
Why use many words when few do, right?
What else about this was kind of what made this tough?
And I'll add to that not only is it you're reinventing the wheel here, but even if you didn't have a wheel and you needed to invent it, what should you do with a chunk of code like this? What is this screaming out to you? Put it in a method, right? Reorganize it and put it somewhere else, so that it looks like the original. I'll write my own sorting algorithm. I have to because I can't afford one, so I'll go ahead and write it, but I'll put it into a method.
Anybody else back here?
Oh.
I heard variable names. Yeah, go ahead.
Variable names. Go ahead.
Yeah, so the variable names just don't really tell me what's going on. So, like, when you go down and look at, for example, the mini index, like, why do you need a mini index? So maybe...
Where's the mini index? Hold on.
So maybe just putting even, like, just some, like, / and explaining what that mini index do would maybe help. But just telling me that it's a mini index doesn't help.
Okay. So bad variable names, IJK, scoped all the way at the top.
Sorry, just when you say bad variable name, just because I am totally unfamiliar, what's a bad variable name?
So a bad variable name is one that is not self-explanatory of what it does.
Okay, so like you would in code define the variables above or like early in the code so that you would know later on. I feel like that's like writing. Like when you use new terms, right, with a reader, you're always going to want to define your terms in the beginning so the reader knows what you're doing. But yeah, that sounds super important.
Writing also word choice, right? Choosing an adjective that describes what it is. Choosing a variable that tells you what it is, right? Temp and temp2. Okay, what's the difference between them? How are they being used?
And so I think, like, that being said, we don't all just kind of like spit out code that's perfect on the first try, right? So like that's kind of what this is about too. Like maybe this is your first draft, right? Maybe this is your first draft.
In fact,
a lot of people are like, that would not be my first draft. But maybe it is, right? And like if you go ahead and reverse outline this, it might expose to you that, oh, the variables aren't defined. That's something I need to fix. I think like for me, I am like, someone needs to, I'm very like task oriented. I can't look at something and like know what's wrong. But if you give me a task, then I can kind of like figure it out. So if I had written this code, what I would do to revise it is like make that reverse outline and then try and find my redundancies and refactor.
And what's another piece of evidence that you can tell that this is a draft? Yeah.
Dead code right at the top.
Dead code, right? That was debugging code at some point, and then somebody just commented it out, but left it in there, right? In a second draft, do you leave? I'm going to go ahead and delete this line. I'm going to delete this sentence. I'm going to rewrite this sentence. Do you keep all of the old stuff that you wrote? No, you get rid of it. Don't leave dead code. Don't leave garbage writing.
So overall point here. Reverse outlines are awesome. Again, I use them so I expect to write at least 3 drafts of anything I write, which is laborious, but that is life. And reverse outlining really helps me determine like what I need to do in that next iteration of a draft. And I think it can also really help when you code. Okay, so let's move on now to design documents. So by the end of the semester, you all are writing design documents, and I think your first draft is due Friday, right? The 6th?
Correct. This Friday.
This Friday.
Hard copy in my hand on Thursday or in my mailbox at the main CSE office by Friday, 5 p.m.
And one of the other things we wanted to do in this presentation was talk a little bit about like, okay, you have this new writing task that you've never had before. Like, how would you go about knowing what to write or like how to format it? So just talk with the person next to you first. The first thing I do when I'm doing something new in writing is try to find a little bit about the genre or the type of writing that it is, which is like, what exactly is a design document? Who is it for? And why is it important? So go ahead, 2 minutes, talk to the person next to you. Can you answer these 3 questions about a design document?
It's literally just like, yeah, we did these things. This is why. This is how it works. If anybody's expanding upon your
It's important because nobody understands how to use it.
Let me know if you do that again. We moved last year's class.
Got it. That's true. That's true. Okay, I'm curious about the answers to these questions because I myself have only a limited understanding of actually what a design document is. Any folks over here willing to tell me what it is, who's it for, why it's important? No, a lot of avoiding eye contact. It's a very, very effective way to not get me to pass you the microphone. Anybody over here?
Is it because we enjoy reading them? No.
I'll at least endeavor to answer one of them. So who is it for? It's for people that don't really know code. It's for people that need to understand what you've made, but can't read the code to understand it.
Or alternatively, somebody that does understand code and needs to implement the system as well, right? But definitely for a non-low level technical audience.
Anybody over here? I'm pleading. No. No. So what exactly, like, what's in it? Like, so it's a document that's like for somebody who doesn't read code, but like, what is the content of the document?
You might find examples of pseudocode, that is code that is written in more plain English for someone who doesn't have that high degree of technical understanding of the language.
Got it. So would pseudocode kind of be like a reverse outline of sorts, like this first the code will do this, like that sort of thing? Very similar to that. Okay.
Or at an even higher level, how a much more complex system has multiple moving parts and components and how they interact with each other and how they fit together.
So basically, you open a design document and there's just pseudocode. Yes, no.
You will also find stuff such as milestones and updates on your original plans to implement the code or the team's individual plans.
Cool. Okay, so
Revision
modifications, history. So basically, it's going to go pseudocode, revision history. Yes, no. So how do you know? Well, this is a good question. Okay, so you don't know the answer to this, right? You're like, okay, I don't know exactly where to start with this. I know that the design document has to do some sort of things. I kind of know who it's for. It's for a wide audience, right? So maybe going right into the pseudocode could still be confusing for someone who doesn't know kind of the overall process of what you're trying to do. So you're in this class right now, and you need to write a design document. Where would you find out the information about what it is? Like, you need to write this by Friday. Where would you go to find out what a design document is? The answers to basically these questions. Canvas. Cool. Do you know where on Canvas? Yeah.
There's a couple of articles on this class's Canvas homepage.
Cool. The Canvas homepage. Here is a screenshot of one of the Canvas homepage.
Under assignments.
Under assignments, thank you. And here you've got this happy little title, Overview and Requirements. And should you click on that, a document come up, and even just this sentence kind of explains a lot of the answers to the question. So the design document should be clear and comprehensive enough that a reasonably technically competent person could reproduce your system design, though not necessarily every detail with identical functionality without access to your actual code base. Our evaluation will be based on how well your design document achieves this principle. In addition, we will also evaluate your technical writing skills by evaluating the following items. And then there's a bullet point list. So this is a place to start, right, with what your design document. And there's a couple like clues here that I, as a student, would take note of. Just this like clear is mentioned, and audience, kind of someone who's not intimately familiar with your code, right? People kind of talked about that. So that's really important. The other thing that's really important if I'm a student figuring out how to write a new piece of writing is looking at samples. And if you look down below, you've got a professional example and some student examples. So what we're going to do here is just take a look at how I would open this professional sample and look to kind of imitate it in some ways. Like, how actually do you look at a document and know how to kind of transfer that use it for your own project. Okay, So here is a page in a design document. And so first I'm just going to have you notice this, like, so actually first we're going to think about it. One thing I think about when I look at a new piece of writing is those reverse outlines again. Is thinking like, if I have a new piece of writing, like if I've never written a cover letter before, right? And I'm like, what do I even write in a cover letter? I don't know. I would take a sample of a cover letter, like that one I showed, and I would reverse outline it. Like, okay, in the first paragraph, I introduce myself. In the second paragraph, I talk about why I'm qualified. So take a second with a partner and just go ahead and reverse outline this. Take a second. What is happening here? And what is happening here? And how do you know? What would you write as the function of each of these sections? So talk with the person next to you. And if you're confused, just talk about why you're confused. It's totally fine. Okay, what did folks get? What's the kind of goal of that first paragraph? Anybody here? The first paragraph. You don't have to be right.
To show off the different steps they're going to take.
Cool. So under approach, the approach is like, here's like all the steps that my design is going to do to like solve this problem. So it goes over, kind of gives an overview of the entire document in some ways, right? Like an overview of the process. Cool. How did you know that that was the goal? Like what?
Approach. Yeah, go ahead. It says approach.
Awesome. That is a great answer. Do you know why? So basically what you're telling me is it was really easy to know. And it was easy to know because there's a giant title there that tells you exactly the function. So what I'm taking from this as a person who has never written a design document is that like, hey, super clear and super obvious, right? So I should write a title at the top of every one of my sections that super clearly tells that reader what is in that section. So that's awesome. What about the second one? Anybody, second section, goals.
The system requirements and why those are hard to implement.
Constraints, right?
So that's part of, constraints. Anything else that it does? I mean, you can read the title. What's the other major part of the title? Goals. And you'll notice that first sentence says the overall architecture goals of this system is. Like, that's a pretty direct sentence, right? You've got the title and then you've got this really clear sentence of here is the goal. So these are really important linguistic features to pay attention to when you're writing this. So was this easy for you to reverse outline? This is just a nodding one. You don't like nod yes or nod no. I just want to get a sense. I'm going to look over the entire room. I got a lot of nods yes. Cool. So this is kind of more akin to that first code that you saw rather than that second code. So I want to talk a little bit about why this is easy to reverse outline. And one answer we had was the titles, right? The titles make it really obvious. Talk with the person next to you about try and notice some details that you might want to imitate, actually, about why this is easy to read and why this is easy to follow. Okay? Take a minute. Go for it. Okay, I'm curious. Why is this easy to read? Yeah.
They break it up pretty nicely with like bold font, and then also using bullet points for each section and different formatting things with LaTeX.
Instead of big giant paragraphs with many sentences that you have to sit there and parse out and read, it's all separated out into a bullet pointed list.
Yeah, it looks real pretty. That's what I thought when I looked at it. It looks really nice. And I think that makes it totally easier to read. And someone mentioned that on the code too, like spacing and formatting totally matters.
Look at where there are paragraphs. Count up the number of sentences in each paragraph. What do you notice? No more than 2.
Yeah.
2, 3, 4 sentences in each paragraph. Get your ideas down to just the crisp technical stuff, right? That's what technical writing is. You're not Oscar Wilde. You're not writing poetry. You're not Thomas Wolfe writing a big giant tome of a book. You're using language to convey knowledge. You don't need a lot of flowery language. You don't need a lot of adjectives. You don't need to say things over and over and over again if you've got one crystal clear sentence that gets your point across.
Anything else you're noticing? I'm going to just look at a couple of language things that I thought were really nice. Not only does that first sentence there's just a lot of, I think, cohesiveness in the document that I was really impressed by. The first being like, there's this title here, and then the first sentence is like, the overall goal is, right? It just immediately, the words are following from that title. And when there are 2 sentences together, there's an acknowledgement of how those sentences are connected. So I want to draw your attention to just down here. A key architectural goal is blah, 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 blah. To meet this goal, the design of the outline screening tool, blah, 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 blah. What I love about this is really this transition. It acknowledges like what the thing before said, what the sentence before said, and builds off of that. I think that when you're reading something fast, making those connections kind of explicit for your reader makes a document kind of go over a lot more smoothly.
Now, there are some things here that might violate what you generally want to do in code. For example, naming your variables, descriptive names. What we have here is examples like TANF. What the hell is that? J2EE. What is that? Where in a technical document would you go to find out what that is? Glossary, exactly. Or accompanying a glossary is going to be an acronym index. And that's exactly what we put into your template. And if you look at these documents in full, you'll see that those are explained elsewhere so that you don't have to write whatever TANF stands for over and over and over again. You can shorten it up. And by the way, if you need to know what this is, there's a proper place that you can find it.
Cool. I'm going to actually zoom in. I'm going to make this one a little bigger and zoom in. And I want you to notice the language now. So individual words and structures that are helping this, that are helping this be easy to read. So go ahead. Again, a minute with your partner. Go ahead. This is the
I don't know, what is APA style guide? Periods after bullet points?
Oh, I don't know.
They did here.
Yeah. Okay, I'm curious. Anything like language wise or like the structure of the sentences that made this like kind of easy to read?
all the bullet points kind of follow the same pattern. They say during this phase, this will happen for this next phase too.
Cool. That actually has a name. It's called, does anyone know what it's called? In writing? No? Parallel structure? Have you ever heard that? Yeah, it's like where it's where you kind of, in order to show that each of these kind of follows the same structure, you've italicized this. Even the sentences follow parallel structure. It's when you want to indicate that 4 elements fall into kind of the same general category. You notice the sentences begin during the this phase, this happens. During the system design phase, this happens. Right? Just, it may seem repetitive, but it also makes it hella easy to just go in and find, exactly where information is.
You're not reading these for an enjoyment, right? Other people are not going to be reading these for enjoyment like you would a novel, where you need, descriptive language because you're trying to imagine something in your head. You need direct language. Technical writing is all about being terse and being exact.
So now you're going to go write your design document. There's a point where I want you to use like these examples for inspiration, right? But you can't just sub out information, right, from this and put in your own, right? Like, just because this document has 4 phases, that doesn't mean your project needs to have 4 phases, right? But if you think about this in terms of the purpose, like you could say, okay, so this section of a design document, from our reverse outline, we know that this section describes the approach, right? It describes the overall steps that the designer is going to take to make this task or this design work. Now, that purpose you can totally apply to your writing, right? But you don't need to have exactly 4 phases kind of in your project that do that. Are the students all far along enough that they have their approach already? I don't know. Are you?
The phasing is kind of prescribed by how we broke down the project and say, in the first 2 weeks you do this part, in the second 2 weeks you do this part. So that kind of design and that kind of process breakdown has already been done for you. But that's because it's in the context of a class. If you were doing this from scratch and you were just given a problem task that we need a system to do this, this, and this, right? Then you would have to, like I think somebody mentioned it before, they'd have to break it down into manageable chunks, right? In the first phase, we'll do this, and the second phase, we'll do that.
What I think you could lift, from this document are what I call sentence stems. So just the transition words, like during the blank phase, we will do blank, right? That you could put your own stuff into. But I think there's a tendency, especially when looking at student samples, to just like sub out entire words. Like maybe, your project might be in phases, but maybe it makes sense to talk about it, in another way. Like, maybe you're not doing, so something that could happen is like, maybe you're not doing the steps, like you're not doing it in time order. Like maybe you're doing, something that comes at the end of the process first. Like you may want to do it chronologically. You might want to do it in phases. So kind of step back and think when you're imitating a section or like looking to take from an example, stepping back, thinking about the purpose, thinking, what are the ways I can accomplish that purpose? I think is a great approach. And again, I'm going to encourage you, take this and use it for any kind of writing that you're doing at the university, right? If, your literature professor asks you to do a close reading of a poem and you're like, what is a close reading? Check Canvas, find that stuff, get a sample, and scrutinize those paragraphs. What is happening in the first paragraphs? Oh, I noticed that in a close reading, the quotes are only 2 and 3 words long. That's important. But like if you develop your kind of powers of observation for these type of samples, you'll be able to write anything by looking at, examples in whatever field you want.
And when you read the student examples, understand that those are a different project. And understand that you do not copy directly. That's plagiarism, of course, but also it won't make any sense because it was for a completely different project from a couple years ago or something. I forget what it was. Don't plagiarize. And in fact, what I would suggest that you do is you take the student sample, you read through it, and then you put it away. You don't look at it again, right? Then you go and you draft your document so that you know that you're not lifting wholesale from this other document over here. Instead, you just have the idea of what a good example
Those
looks
purpose statements, yeah, you are a lot less likely to plagiarize when you're looking at those purpose statements more broadly. Okay, last one. Talk about why this one is easy to read. Why is this effective? 1 minute with your partner. Go. Yes, we're at 12:01. I plan to do like a real quick overview of this one, and then I'll just intro the writing center.
You're okay with YouTube again?
Yes, totally. Thank you. It's actually kind of cool.
Okay.
Sent it to my dad. Okay, cool. What comments on this one? Any comments about what this tells you? Why it's easy to read?
So like there's no boring paragraphs and stuff. So like there's a diagram and like you can like straight up go into because like the arrows help that too. So
yeah, the arrows really help. I mean, can you imagine what this would look like if it were words?
10 pages of text, right?
That would be incredible.
What's the old adage? A picture is worth what? 1,000 words. Don't write 1,000 words. Draw a picture. In fact, better yet, use a tool to generate a picture for you. Right?
I just thought this was cool because this is kind of a complicated relationship structure, right? Like it's easy to write about something if it's linear. That's really easy because one paragraph can kind of follow from the next. But this is totally not linear. Like, you know, if you started with this and then went to this and then this, then maybe this, but like, how do you know which one to do first? Maybe that, but this just gives me a really quick overview of the relationships with these things in the document. So,
and you're able to focus in on one part at a time if you need to. You can focus in and see that this is some sort of a sync here, that everything is related to it, but it's not related to anything else. So you can, you can focus on that one piece there, one piece at a time. You don't have a cognitive overload. This is called an ER diagram, an entity relation diagram. You will be producing something like this. And it basically describes the tables in a database. And the arrows describe the relationships between those tables.
Okay, so that concludes our content part of the presentation. Just to do kind of an overview of what we did today, we talked about kind of 3 techniques that are both useful in writing and coding. Free writing, right? So if you're stuck thinking about what you want to do in advance and just kind of getting all the stuff you know on a piece of paper and then going to write your code after having thought about kind of the overall picture first can really help. Reverse outlining can also help with writing because it can give you the structure of a document, but it can also, on your first draft, tell you what revisions you need to make. Also helpful for coding because you can reverse outline your own code and say, like, where are my redundancies? Are my variables defined, right, in the beginning versus in the third paragraph. And finally, we went over kind of like, how do you analyze a piece of writing that you're going to write for the first time, a new piece of writing? Like, we went through that document pretty closely. That is the way that I learn how to write new things. Another place you can go to do all of these things is where I work, the UNL Writing Center. So this is our space in Andrews Hall, which is really close to here. And you'll notice they've got, tables set up here for 2 people. And basically what happens is you meet one-on-one with either another undergrad student or a grad student. You can come from any discipline. Our undergraduates, consultants come from any discipline. We have microbiologists, we have political scientists, we have everyone. They all take a class on consulting writing. So they all are trained to kind of ask you the questions. And they probably, like, when you'll come in, you'll check in at the front desk, you'll go sit with your consultants, and they're going to ask you a lot of those main questions that I asked you, like, what's a design document? Why is it important? Who reads it? Like, what are the features that make it a design document? Do you have a sample? And they are really good at kind of noticing what features about a sample make it good. So they can kind of do the process that we just did with you. And that's even coming without writing. You can just bring a sample of writing that your professor has given you and you're like, I need to do this, but I don't know what the kind of, I'm having some trouble identifying like what features are most important. A writing consultant can talk you through that. I want to highlight that you can come at any stage. You can come when you have that first draft and you're like, I want to make a reverse outline. Can you do that with me? I want to work on polishing a final draft. So we work on anything. And it's not just for writers. You can totally come if you really struggle with writing. Writing is really, really hard. I think it's one of the hardest things. That's kind of how I got into this, because I was like fascinated by just how hard it is to put words to stuff. But you can also come if you're a strong writer, because every writer needs a reader, right? If your documents, I don't care if they're code or design documents, whatever, are going to be read by another person, it's super smart to get an audience for that piece of writing before it goes to the professor. Chances are you could get feedback about formatting, feedback about the sentence structure type of things. So that's kind of what we do. And we're really like, all the undergraduates who work there are really sensitive to how hard writing is, and they can give you a lot of like new techniques to kind of get you through when you're stuck. Or again, just provide you with that other set of eyes. So you can make, go ahead. You can make 25-minute or 50-minute appointments. Our main location is Andrews Hall, and that's from 9 a.m. to 5 p.m. Monday through Thursday, and 9 a.m. to 12. I have all this information. I have some bookmarks that I'll leave on the front table with kind of all of our website information and things that you can grab on your way out. In addition, because I know, some people work or have class during the day, so it's kind of hard to get to the Writing Center during the day. We also have evening hours from 5 to 7 in the Adele Learning Commons, kind of just to the right of the Dunkin' Donuts. We have other satellite locations, the Gone Multicultural Center, Nebraska Hall, East Campus Union, and you can find all those on our website, which I'll pull up real fast. Yeah. So when you sign in to our website, you will see a schedule an appointment button, which will bring you to this screen. I'm just going to go ahead and type my username and password real quick. So here is what will pop up when you sign in. And what you can see is we've got all the different consultants. All the different consultants right here. All these blue things are appointments that have already been reserved, but any of these open slots are fair game for you to sign up. If you click on one of these things, the consultant's profile will come up. And that includes kind of their major, what year they are, just like general information. But you can scroll down if you click right here. Up at the top, that one. Awesome. You've got all our different locations. And the last thing I want to do is just highlight the Nebraska Hall location. So this is our like engineering specific location. Cool fact. I just want to tell you who uses us on campus. Our highest percentage of users is actually first years, like students would that come in and they're doing writing in college for the first time. The second highest usership are grad students. And we also did a department analysis of like what departments are students coming from. The first is College of Art and Sciences. That's the highest percentage. Second, engineering. So a ton of engineers are coming to the Writing Center. So you're actually, in terms of all the colleges at UNL, you all are the second highest users. So people are coming, which is kind of exciting. And then lastly, I've got to click on this. I just want to do one more. Oh, perfect. Yeah. I just want to highlight the engineering satellite. Again, these hours are on the internet. But it's in that kind of glass Olson room section of the engineering library in Nebraska Hall. You can come to any location, but these are kind of set aside and they're kind of near the JGen classes. That's why we set it up in this location. But I would highly encourage you. We don't just do academic writing either. If you have job applications, resumes, that sort of thing, you can also bring that stuff to the Writing Center.
In fact, remember that the STEM job fair is next week. Even if you're not looking for a job, even if you're not looking for an internship, even if you think you're unqualified, rethink that you are. The majority of our freshmen after their first year have internships. So prep your resume. And even if you're not looking or seriously, get your resume out there into 50 different resume banks at once, and they'll eventually be calling you to recruit you rather than you having to go out and apply to 100 different places.
And we work with you kind of on all levels too. We'll do sentence structure and grammar. That's something we totally do. We'll also do overall structure of your piece, but it's just kind of a cool place. So just bring, when you come, bring your assignment guide, any samples, any writing you have, feedback from your professor, all of that stuff. It's really nice to be able in a large university to kind of sit down one-on-one with a student. I myself had a lot of trouble writing in college for the first time, and going to a writing center, it encouraged me, it made me more confident to speak up in class. It made me kind of able to practice talking about information with another person in a really low stakes, supportive and comfortable environment. So I think for me, and now I'm talking to so many people, I've really come a long way. And I think one-on-one consulting is a really special and awesome thing that can really help you. Also, if you're the kind of person that is always late and procrastinating, make a writing center appointment as a self deadline. That is key. So if you have big writing projects, sign up before, come with unfinished stuff. That is the best time to come, is when you have unfinished stuff. But sign up in advance, give yourself deadlines. Our cancellation policy is liberal, but you can always get something done by talking to another person.
All right, thank you, Dr. Steck.
Thanks very much. Visit us. Good luck.